Alright everyone, today we're going to be working in Onshape to and doing a little bit more of a complicated assembly, but a little bit more of a practical assembly. So we'll head over to our Onshape team, into the off-season folder, and then we'll go into presented practice documents, and you guys can follow along to this video in your own Onshape folder. So go to 2020 Drivebase practice assembly, and we'll go into the document. So here we have a drawing, but we'll look at that a little bit later. What we have is a selection of parts here that we'll have to assemble into this completed Drivebase. And I've simplified it a little bit. I've taken out some of the mounting hardware, and I've grouped some things together just to make it as streamlined as possible. But effectively, this is going to be what we're going to be assembling. So what we've got here is a 6-wheel drive tank drive called the West Coast drive, with 4 traction wheels, which are both driven, and then 2 omni wheels, which are not driven. And the omnidirectional wheels, the reason they're there is just so that you have, they can move sideways more easily, so that when you have them on the front of the robot, when you're turning, you're not going to skip up and down when you're turning. The general rule for turn scrub is that if your drive base is longer than it is wide, you won't be able to turn. But if it's wider than it is long, like this, you will be able to turn without needing traction wheels. Because our drive base is roughly square, we have traction wheels, or we have omnidirectional wheels on, just as a precaution, and as to enhance maneuverability. And then we have our 2 gearboxes here, and there's a chain here. And you can see that there are, of course, having the bearing blocks on these omni wheels is actually not entirely correct, but just for the purposes of this assembly, we'll leave it as is. But basically, these bearing blocks, what they do is you put the shaft of the wheel through, and it spins, and then you can sort of slide the wheel back and forth on your drive base rail. And what that helps you do is there's a tensioner attached to here, and it pushes this forward. It's sort of shaped like a shell, like a Nautilus shell. And then when you twist it, it pushes this bearing block forward and tensions your chain. So that's super helpful to have when you're assembling this in real life. Now you can see if we go here to our reference drawing, we have an exploded view and a reference orthographic view. So this can be used as reference when actually building, and we'll get into how to make this drawing at the end. So we'll go here and we'll see the parts we have. The first thing to do is going to be to assemble our drive base frame. So that's going to be these front and back plates, these front and back drive base rails, and then these side drive base rails. So the first thing to do, we're going to use these gussets. And now the aim of this assembly is going to be to most closely emulate how it's done in real life, right? So in real life, we have gussets with bolts through them, through these pieces of VersaFrame, which are connected, and the gussets sandwich around them. As to whether or not you have to have bolts in the CAD, some people really like bolts in the CAD, some people don't. But I think it's a matter of preference. Personally, I think it's a waste of time. I think they're implied, but that's just my opinion. Do whatever works best for you and whatever helps you be most efficient. So the first thing we're going to do is fix one component, because you always need to have a fixed component in an assembly. Otherwise, when you try to actuate something like spinning these wheels, the whole thing moves around. So we'll right-click this bit and press Fix. Okay, so now if we try to drag it and move it around, it's fixed. See, that's the little fixed component there. See? So next thing we're going to do is we're going to start mating our gussets and our VersaFrame together. So we've got our Fasten Mate, or you can just press M. We're going to be mostly using Fasten Mates and Revolute Mates. Now Revolute Mates are usually what you want to use between circles, and they allow the center point, they allow circles to spin within each other, which is going to be used for our wheels down here, more specifically the axles. And then your Fasten Mate, which limits all degrees of freedom between 2 points. So we'll get started with that. So I'll press M, open up a mate dialog window here, and then we'll go ahead and start by selecting this hole. Now the reason we know it's the 4th hole down here, for the center of this gusset, which we'll have to reach on the underside to grab, the reason we know that is because because we looked at the reference. And the reference build has 2 holes poking out from next to the gusset. So that's what we'll do, and you can see that there's 1, 2 more holes that are open there, that are exposed. So now we'll move back to here, and we've got this gusset. So now we're going to press M again, open up our faceted mate, and the first showing hole will mate to the first hole on this piece of versa frame here. And see that moves over there, press check. Now if you press this check, it'll allow you to do a new fastened mate right after you're done. But if you press this check over here, it'll close the whole operation. The whole, you're not going to be doing another mate. So if you press fastened again, we can go ahead and add another gusset. And you can either look on the underside to grab the underside. If you grab the overside, the top side, it won't always, or it'll go through what you're wanting to grab. So you can either grab this hole on the underside like this, or you can go through on the top side if you don't want to change your camera orientation like that. So you go like that, and click the 4th hole, click it, press check, and then see just because we pressed that check there, we've still got this dialog box open, so we can click this, and we're good. So I'm going to go ahead and so we're good on this. And the next thing we have to do, we'll close out of this window, is we have a bit of a problem here because our gussets aren't turned around, right? We need these T gussets to be facing inwards in order to mount this piece of versa frame there, right? So what we're going to do is highlight, and you can highlight these like this. There's 2 different ways to highlight. You can go down, which is blue, or no, right, which is blue, and left, which is yellow. And for the blue highlight, it'll highlight anything that's all the way in the window, but nothing that's not mostly in the window. But here with the yellow one, it'll highlight anything that has any part in the window. So if you do this, it highlights all 4 of those. Which way you use them, it's really a matter of preference, a matter of context. But I usually like to use the blue. It gives you a little bit more precision, but it doesn't really matter. So we'll go ahead and rotate that 180 degrees, which is all the way around, and we're good. So now we can press M and go through here, grab that, go to the 4th hole, fasten that, go in through here, and grab this one. Now we check this, and the whole thing moves forward. So now everything is constrained, and we're just going to go ahead and add the rest of our gussets. Okay, and adding our last gusset on here, we'll select the top face there, and we'll select the bottom hole here. We don't need to select 2 just because it's fully constrained already. And now we have a put together Drivebase frame, that's the first order of operations for this. See, none of this is going to move because this is fixed, and it's all attached. So the next thing we're going to do is add our bearing blocks. Like we talked about, they help the wheels to slide. So you can see that despite the fact that this is a bunch of parts and there's actually no mates connecting these, they still, if you move one, it moves the whole thing. And that's something called a group. And groups are super useful for imported components like this Omni wheel. You can just highlight everything and press group up here, and it mates everything together, like a fasten mate, but for everything together, so nothing moves. And it's super useful, for components that you're working on, that you're importing, or assemblies that you're transferring. Like this is all transferred from Inventor, which was the software we were using last year. So none of it had mates. I just put groups over everything and called it a day. So that's the way we're doing it. Now we've got to mate this bearing block onto this hole, but we need 5 more of them. So what we're going to do is highlight this. We can use the blue highlight window and right click and press copy 6 items, or you can just press Control C for copy. It really doesn't matter. And then you can press paste 6 items, or you can press Control V. Oh, that was 2. Control Z to undo. And then what we've got 4 now, so we'll need 2 more. Control V, Control V. So now we have these things copied and pasted, but if you looked at this one, right, if you move it around, it moves around properly because it's a group. You know, it's a group, it moves together. If you move one of these, you're not so lucky, you just get individual movement. So Control Z to undo. And what we can do is just go ahead and group all of these. So highlight this, group, and you can name your groups. I like to name mine sometimes, but if I'm doing a bunch, you know, it's not really worth it. So I'm just going to call it bearing block assembly. All right, so now we've got a group, and now if we move this around, it's going to move as a group, like that. Yep, just like that. All right, so now we're going to group the rest of these. Don't need to name that. Just do it just like that. And it's really not that complicated, but it's a super useful tool to use when you're making assemblies. Okay, so now we have these all grouped, and we're going to go ahead and mate them to the holes in the Drivebase where they would actually mate. Now, they wouldn't actually mate that way because they can slide, so we could use a different type of mate for that. But for now, just for simplicity's sake, we'll use a fasten mate on these holes. If you used a revolute mate, the bearing blocks would kind of spin. So what I'm going to do is press M here and select this circle of the bearing block here, which is the circle around which it's mounted, and then I can go through and select this outer circle of the 2x1 of the Drivebase rail. And if you look, it was all, you know, already configured properly, so it'll fit properly. And we can press check, and we can do the next one. Click on this circle. Sometimes you have to zoom in a bit, and then we can do the outside this time. And press check, and we'll do the rest of those. Okay, and we'll finish that up. And now we've got all of our bearing blocks on the Drivebase, which is good. So next thing we're going to do is copy these wheels, and we're going to have to do the same thing. We're going to have to copy them and regroup them. If you can probably copy and paste, and copy-paste operations aren't super taxing. If you want to copy this, you can. You know, copy them all at once. Sometimes it would help for them to be, you know, copied in groups. But I'm going to say this, copy 270 items. And the more items, because Onshape is cloud-based, it really depends on how fast your Wi-Fi is, how quickly and how well you can, you know, get stuff, run operations. And when you paste something in with Control V, it goes where your mouse is, which is helpful sometimes. So next thing we're going to do, and if we try to rotate all three of these at once, it would take a while, it wouldn't be any fun. So what we're going to do is select each one of these individually. We're going to group it, because when you copy things, they ungroup. And then we're going to select this and rotate it 180 degrees. All right, same deal with this. Group it. And then since it's grouped, you just need to select one bit and rotate it. And the thing about CAD, you know, for design is it's a lot of busy work. It really is, especially assemblies like this. But the idea is to be able to streamline that process and refine that process as much as possible. That way you can get your ideas to most effectively translate into the software. Because that's the ultimate aim of CAD, is to be able to show your ideas in a language that, you know, other people can understand, and in a method that you can critique more easily. You can just name this Drive Gear Box 2. And that, rotate it. And call it a day for that. So now we just have to insert all these components. And these drive gearboxes actually go on the inside, so we'll do those first. And that's just a fasten mate. We'll do that. And see, if you select this face here, it'll give you all these different mate connector options, which are, I mean, it's what Onshape thinks it, you know, you should mate from. I don't think it's, you know, typically you just want to select a circle, but if you want like the center of this face, you see it auto selects the center. It makes that little checkerboard. You could select each one of these make connectors if you want to. I just like to go with the circle here. It makes the most sense. But if you go here, you can also select the circle. And at any time, if you ever need to delete a make connector that you selected, just press X, and it's deleted. And you can hold and drag even while you have the mate dialog window open, which is good. All right, so now we'll mate that to the bearing block, like so. And we have one, and we'll do the same with the other drive gearbox. The same with the other drive gearbox. And if it's not, the thing about fastened mates is that it doesn't, orient it. Like if the z-axis, which is the straight up one, is oriented improperly, your rotations will be off. So you might just have to do that manually. Again, this CAD is just, it's just a reference for how to actually build it, right? So the goal is to have it, close enough, right? I mean, as close as possible is ideal, but sometimes, there's things that you can't really control, and you just have to get things close enough. So we'll click that, and we'll click the outside of this bearing block, and we'll click this bit of the bearing here. See, and these little pieces are bearings. This is a shaft collar which holds this hex shaft. It holds it down so that it can't slip out, so the wheel won't fall off. And this is a bearing under here. It's a flanged hex bearing, 1 1/8 inch. And we'll repeat that process for these wheels on the left side of the drive base. Oh, you know what, actually, I forgot is that we're not doing it. These wheels shouldn't be fastened mates, they should be revolute mates. Smooth brain. Alright, so revolute mate. The connectors work exactly the same as the fastened mate, except when you go ahead and click this. So at the moment, everything on the drive base is fastened. It won't move. With this, if you put it on here, and I go ahead and say check, and you spin it, and because there's a lot of geometry, it's going to take a while to get spinning. Right, it's going to take a while to tessellate, but it'll do it. See, it's spinning, like that. So yeah, that's how the revolute mate works. And if you press M again, it goes back to the fastened mate, but revolute mate is what we're going to do for the rest of these wheels. And you can name anything in Onshape, which is super useful. And also, if you go in this little toolbar here, if you double click on anything, you can edit as well. So if we go to this revolute mate here, we can double click on it and edit it however we want, or animate it. Or animating it would actually be with a right click. We'll do that later. So check mark there. And we'll do this one. Revolute spacer. And there. And when you get mates between circles, it just puts the center points of the circles together, and you can offset that however you want. Although you can only offset it in this direction. You can't offset it in X or Y, or relative X or Y rather. Only in the relative Z can you offset it, which I guess makes sense for revolutes. That makes the most sense. Yeah, sometimes you have to click things a couple times just to get them to register. But alright, so we go ahead and do the rest of those. Okay, and check that last one, and now our drive base is fully assembled. So the next thing we can do, and is something that's really just, for style points, but you can go ahead and click a gear relation. Now relations are mates between different mates. So a gear relation naturally is between two revolute mates, and it'll make them spin in opposite directions, but you can reverse the direction so that if you spin one of these wheels, it spins this one, and then you can attach this one to this one, and so on, right? So what we can do, and we'll just do one side of the robot, we'll click, revolute 5 and revolute 6, and reverse direction. Relation ratio is 1, that means one in is one out on the other wheel. And And we'll do the same thing between 5 and 4. Reverse the direction. And now, if we go ahead and right-click Revolute 4 and click Animate, we can click Reciprocating Playback, change the steps, which just makes it faster, and change that end value to a much higher degree to make it go longer. So now if we play that, it'll take a second to load, but it's going to spin all the wheels. And at some point, we forgot to properly change the gear relations, I think. Yeah, see, they're all spinning. These two are spinning properly together, but this last one isn't. So what we'll do is we'll check. I think this one's Revolute 4. So it's gear 2 that we don't need to reverse the direction, actually. Now if we try animating this again, yeah, see, now they're all spinning in time with each other, which we want to make this go longer. Not that many, but, and then steps is the amount of steps it takes to get from 0 to, or the amount of steps it takes for each degree of rotation, I believe, or for each full rotation. Now if we do this, they're going to spin real fast. So that is the Drivebase, and that's fully assembled. So next thing we're going to look at is the exploded view, which basically I won't get too much into detail with it, but here we have the completed reference, which you can see that they're the same because that's how we assembled it. And if you go to exploded views here, just get rid of this window here. If you double click explode 1, it goes to this exploded view, and this was something that I created. If you go into exploded window and click add an exploded view, we'll add one. We'll name it demo. Once that's added, and I can click this and move it, and then a little dialog window pops up. We can say we want it to move negative 10 inches back. Okay, that's cool. We got that. That's good. But and now so that's our exploded view. We just moved one over. We go back to this one. It's the full exploded view that I made earlier. Basically, just dragging each one of these components out together. Now, another thing you can do is say, oh well, obviously these gussets are going to move with this piece of VersaFrame, so we can click all of these gussets, not this piece. I'll unclick that. We can click all of these gussets, and they'll add themselves to the exploded view. They'll move backwards, the same amount of inches that the piece of VersaFrame moved backwards. And you can toggle between translation and rotation in this little pop-down menu there. All right, so that's basically it. Here we have a reference sketch that we made. It's really not complicated. You just go into this, and you right-click. You say create drawing of. Okay, we'll make a drawing of this. Drawings aren't really that complicated, but they're super useful, especially for like manufacturing and stuff. And we can here change the view orientation to isometric, which is just isometric means like from the corner view. So now we're going to, and Onshape is a little slow sometimes when it's managing anything on my Wi-Fi, but yeah, so then we can click that, and then if we want to, we can add dimensions, we can add notes on it, we can add callouts, examination windows, all sorts of things that you can do that really they're useful, but they're not necessary. Really, all you need is something like this, where you have an exploded view, which helps with assembly. If you wanted to do a drawing like that, you probably would want to include bolts in your CAD. But yeah, just so yeah, just it's very simple how the drawing works. And then if you want to right-click this, you can go ahead and toggle some things, move it around. If you right-click it, you can say display state or explode position. We don't have an exploded view on this part, but if you had one, you could say explode 1, or we named ours demo, so it would come up as demo exploded view and it would show up in the drawing. And then, you can change all sorts of views. Just, play around with drawings. We might go more into detail about that later. Probably we won't. But yeah, it's a good tool to have. And if you make a drawing like this, this is just, see if we right click this, we can say explode position, explode 1, which is the explode that I made before. But if we wanted to update the workspace, so if we want to update the assembly, now if we go here and right click this and say explode position, we can add demo to our explosion. Explosion. And because, and you can see that, our new explode shows up here. And here we can also say hide shaded view, which this is this is the standard view in drawings, no shading, just visible edges. And we can toggle between different view options. So we'll say show shaded view because that's probably what we want. And we'll right click this again and say explode position default. We don't want an exploded view. This is a reference for the completed assembly. All right, so yeah, that should be a basic crash course on how to do basic assemblies for FRC. Like I said, it's not really anything complicated, just a bunch of busy work. Importing files, editing them into parts that we can feasibly do, which what we can feasibly machine is, it's not that crazy. So making CAD for the parts that we can machine is pretty easy, which is a benefit of, making parts for FRC. You're not doing any sort of crazy surfacing or plastic molding or, anything crazy like that. It's mostly just drilling holes in metal and bending metal. So yeah, it's really not anything complicated, just, enough busy work to get your idea onto the software. And that way, other people can see it and be familiar with it and give suggestions. And that's how, design is supposed to work, right? It's a collaborative process, and the best designs are collaborated on. So, if you want, you can go ahead and, on your own time, play around with how assemblies work. This is our last meeting, I believe. So, just figuring out that the best way to learn the software is just to put in the hours. If you're interested, if you're on design team, I would highly recommend it. If you're not, at least you have, this much knowledge. I think CAD can be super useful, not only for robotics, but for, day-to-day life. But yeah, I think, it's something that you just have to work for. You have to put in the hours and learn it, because, then you'll develop proficiency. All right, yeah, so thanks for watching, and bye.